For complex numbers, I is equal to the square root of minus 1. I squared is equal to minus 1. I raised to the power of 3 is equal to minus I. And I raised to the power of 4 is equal to . Hello guys, welcome to another Charli video. In this video, I'm going to explain the concept of complex numbers, which comprise of two parts, the real part and the imaginary part. The Argand diagram are how to perform the basic arithmetic of complex numbers, which includes the addition of complex numbers, the subtraction of complex numbers, the multiplication and division of complex numbers. So, what is a complex number? It is a number that consists of two parts, namely the real part and the imaginary part. So we know that complex number consists of two parts, the real part and the imaginary part. Let Z denote a complex number, A plus BI. A is the real part of the complex number and B is the imaginary part of the complex number. This I in front of B indicates that this is the imaginary part of the complex number. The real part of the complex number consists of real numbers, and the imaginary part of the complex number consists of imaginary numbers. What are real numbers? Any number that can be found within the number line are real number. This is the number line. From negative infinity to positive infinity, any number which can be found within this range are real numbers. Example, minus 8 is a real number. Pi is a real number, 3 is a real number, and so on. Therefore, any number within this range is a real number. What is an imaginary number? Numbers that fall outside this range are imaginary numbers. Example, the square root of minus 9 is an imaginary number because the square root of minus 9 does not exist. Z is equal to A plus B is a complex number. And this complex number can be represented in a two-dimensional plane called the Argand diagram. What is an Argand diagram? It is a diagram on which complex numbers are represented geometrically using Cartesian axis. The horizontal coordinate represents the real part of the number, and the vertical coordinate represents the imaginary part of the number. This is an Argand diagram. The horizontal coordinate or line represents the real part of the number, and the vertical line or coordinate represents the imaginary part of the number. Look at how we represent number in an Argand diagram. This is a complex number. Z is equal to 2 plus 3i. This is the real part of the complex number, and this is the imaginary part of the complex number. So 2, the real part of the complex number, and 3i, the imaginary part of the complex number. So this complex number Z is equal to 2 plus 3i can be represented in the Argand plane in this format. Z is equal to 2 plus 3i. Look at the second example here. Z is equal to minus 4 plus 2i. Z equal to minus 4. This minus 4 is the real part. Look at the real parts here. So minus 4 should be around here. Plus 2i. 2i. So Z is here. Z equal to minus 4 plus 2i. Z equal to minus 4 plus 2i. So this is how we represent complex numbers in the Argand diagram. Let's perform some arithmetic operations involving complex numbers. Addition of complex numbers. Solve 3 plus 2i plus 4 plus 7i. Look at the way we do addition in complex numbers. Solution. Open this bracket. 3 plus 2i plus 4 plus 7i. Take like times. 3 and 4. So 3 plus 4. 2i plus 7i plus 2i plus 7i. So 3 plus 4 gives us 7, and 2i plus 7i gives us 9i. So when you add these two complex numbers, 3 plus 2i and 4 plus 7i, you arrive at a new complex number with the real part 7 and the imaginary part 9. Number 2, 9 plus 4i plus 2 minus 2i. Open the bracket. 9 plus 4i plus 2 minus 2i. Take like terms. So 9 plus 2 plus 4i minus 2i plus 4i minus 2i. So 9 plus 2 gives us 11. Plus 4i minus 2i gives us plus 2i. So when you add these two complex numbers, 9 plus 4i plus 2 minus 2i, you arrive at a new complex number with the real part 11 and the imaginary part 2i. Subtraction of complex numbers. Solve 7 minus 2i minus 2 minus 6i. Look at the way we subtract in complex numbers. Open the bracket. 7 minus 2i minus 2 minus multiplied by minus gives us plus 6i. Take like terms. So 7 minus 2, which are the real parts. 7 minus 2 minus 2i plus 6i minus 2i plus 6i. So when you do 7 minus 2, you have 5, and minus 2i plus 6i plus 4i. So when you subtract these two complex numbers, 7 minus 2i minus 2 minus 6i, you arrive at a new complex number with the real part 5 and the imaginary part 4i. Example 2. Solution. Open the bracket. 5 plus 7i minus 4 minus 4i. So take like terms. 5 minus 4i. 5 minus 4i plus 7i minus 4i plus 7i minus 4i. So 5 minus 4 gives us 1, plus 7i minus 4i gives us plus 3i. So when you subtract these two complex numbers, you are going to have a new complex number with the real part 1 and the imaginary part 3. Multiplication of complex numbers. Solve 3 plus 2i multiplied by 6 minus 2i. Solution. This is how we do multiplication in complex numbers. 3 plus 2i multiplied by 6 minus 2i. Just follow the pattern. 3 multiplied by 6 gives us 18. 3 multiplied by minus 2 gives us minus 6i. 2i multiplied by 6 gives us plus 12i. And 2i multiplied by minus 2i gives us minus 4i squared. So 12i minus 6i gives us plus 6i minus 4i squared. Always bear this in mind. For all complex numbers, I is equal to the square root of minus 1. I squared is equal to minus 1. I raised to the power of 3 is equal to minus I. And I raised to the power of 4 is equal to 1. So from here you can see that I squared is equal to minus 1. So 18 plus 6i minus 4 multiplied by minus 1. 4 multiplied by minus 1 gives us minus 4. Multiplied by negative sign gives us plus. So 18 plus 6i plus 4. 18 plus 6. 18 plus 4 gives us 22 plus 6i. So when you multiply these two complex numbers, 3 plus 2i by 6 minus 2i, you are going to get a new complex number, 22 plus 6i. Don't substitute I equal to minus 1 because you want to get your answer as a complex number. Let's take another example. One plus 4i multiplied by 3 plus 8i. Look at the way we do it. 1 plus 4i multiplied by 3 plus 8i. Just follow the pattern. 1 multiplied by 3 gives us 3. 1 multiplied by 8i gives us plus 8i. 4i multiplied by 3 gives us plus 12i. And 4i multiplied by 8i gives us 32i squared. Add like terms. So 3 plus 8i plus 12i gives us 20i plus 32i squared. Recall that I squared is equal to minus 1. I squared is equal to minus 1. So 3 plus 20i plus 32 multiplied by minus 1. 32 multiplied by minus 1 gives us minus 32. So 3 plus 20i minus 32. 3 minus 32 gives us minus 29 plus 20i. So when you multiply 1 plus 4i by 3 plus 8i, you are going to have a new complex number, 29 minus 29 plus 20i. Division of complex numbers. Solve 4 over 3 plus 5i. We divide complex numbers by rationalizing the denominator. This is the way we divide complex numbers. 4 over 3 plus 5i multiplied by 3 minus 5i all over 3 minus 5i. So multiply the denominator by 3 minus 5i and multiply the denominator by 3 minus 5i. So you multiply both the numerator and the denominator by the denominator, but changing the sign of operation of the denominator. So 4 multiplied by 3 gives us 12. 4 multiplied by minus 5i gives us minus 20i. 3 multiplied by 3 gives us 9. 3 multiplied by minus 5i gives us minus 15i. Plus 5i multiplied by 3 gives us plus 15i. And plus 5i multiplied by minus 5i gives us minus 25i squared. So let's simplify this. 12 minus 20i. 20i all over 9 minus 50i plus 15i is equal to 0. So they can cancel each other, remaining minus 25i squared. Minus 25i squared. Recall that I squared is equal to minus 1. So this becomes 12 minus 20i all over 9 minus 25 multiplied by minus 1. So 25 multiplied by minus 1 gives us minus 25, multiplied by a negative sign gives us positive. So this becomes 12 minus 20i all over 9 plus 25. So we have 12 minus 20i all over 9 plus 25. 12 minus 20i all over 9 plus 25 gives us 34. 34 divided by 2 gives us 17. 12 divided by 2 gives us 6. Minus 20 divided by 2 gives us minus 10. So this becomes 6 minus 10i all over 17. Therefore, we have 6 over 17 minus 10 over 17i. So when you divide this complex number, 4 over 3 plus 5i, you have the answer 6 over 17 minus 10 over 17i. Let's take another example. 7 plus 3i all over 4 minus 2i. We can solve this by rationalizing the denominator. So 7 plus 3i all over 4 minus 2i multiplied by 4 plus 2i all over 4 plus 2i. So 7 multiplied by 4 gives us what? 28. 7 multiplied by plus 2i gives us plus 14i. 3i multiplied by 4 gives us plus 12i. And 3i multiplied by 2i gives us plus 6i squared all over. Just follow the pattern. 4 multiplied by 4 gives us 16. 4 multiplied by plus 2i gives us plus 8i. Minus 2i multiplied by 4 gives us minus 8i. And minus 2i multiplied by 2i gives us minus 4i squared. So let's simplify this. 28 plus 14i plus 12i gives us plus 26i plus 6i squared all over 16 plus 8i minus 8i gives us 0. So they can cancel each other. Remaining minus 4i squared. Minus 4i squared. Recall that I squared is equal to minus 1. So this becomes 28 plus 26i plus 6 multiplied by minus 1 all over 16 minus 4 multiplied by minus 1. So we have 28 plus 26i. 6 multiplied by minus 1 becomes minus 6 all over 16. 4 multiplied by minus 1 gives us minus 4. Multiplied by a negative sign gives us plus 4. So 28 minus 6 gives us 22 plus 26i all over 16 plus 4 gives us 20. So 2 divided by 20 gives us 10. We are trying to simplify. 2 divided by 22 gives us 11. And 2 divided by 26 gives us 13. This becomes 11 plus 13i all over 10, which is equal to 11 over 10 plus 13 over 10i. So this is the real part and this is the imaginary part. When you divide 7 plus 3i by 4 minus 2i, you will get 11 over 10 plus 13 over 10i. Always remember that you need to leave your answer in this format, the real part and the imaginary part. Okay guys, hope the video was useful. Please subscribe to my channel. Comment what you would love to see in the next video. See you in the next video. Bye.